Hi everyone, welcome back to my channel. Last time I did this question, cheapest flights within K-stops, with the dice stress algorithm, and today I just want to introduce a different way to do this using an algorithm called the Bellman Ford algorithm. The Bellman Ford algorithm is like a BSF traversal, similar to like a BFS traversal, and it goes through the graph level by level. And I guess the code is a little bit more simplistic compared to the dice stress algorithm. And the difference between Bellman Ford and dice stress is that Bellman Ford can handle the negative weights. So let's start our Bellman Ford algorithm. Basically, I'm gonna define two lists. One is gonna be like the main price list. It's gonna be just like the dice stress, it's gonna be initialized to everything. Every vertex points to infinity. And I'm gonna times it by n. N is the number of vertices there is. And within price, I'm gonna initialize the source here that's passed in as 0 because the price of going to itself, 0 go to itself, is gonna be 0. So we have a starting point there. And then for all the dice stress algorithm, for this case, we're looking for cheapest flights within K stops, right? And K is given to us here. So basically we're gonna do BFS through like a loop. It's interesting because it's not our normal BFS traversal way. So like for I in range K plus 1. We do K plus 1 because we want to go K plus 1 like from here 0 to 3. As you can see, there's two edges, but there's only one stop here. So the answer of how many K steps there are is only 1. That's why we add 1 here to ensure that it's covered. And here I'm gonna make a temp price list. Temp price list is just gonna be a copy of our original price list. It's gonna be a shallow copy. And now I'm gonna go through the flights. So the flights thing where it's like from to price. For source, destination, cost, and flights, I'm going to check if price source equals float, if it's still initialized at infinity, like then we know this is not something on our current level, not a vertex on the current level, and the cost has not been updated yet. So then we don't do anything. Continue, we just skip this because it's not something we want to traverse at this time. It's not on our current level. Since we're doing BFS, we have to go level by level. And then otherwise, if price source plus the cost, the price of the source from the original main price list plus the current cost is smaller than the temp price. So we haven't updated this on the current level yet. Temp price of the destination, then we would update our temp price destination to equal that price source plus cost. So here we're just updating. If it's smaller, it either means it's still at infinity, or we found a cheaper route to that destination on our current level. So we just update it to our temp price list. And I think this is it. And at the end of here, you know how we made a copy, then we're just gonna push all our temp price. I mean price equals temp price. So we're gonna push everything on the current level back into our main price list here. And in the end, by the end of the loop, there could be situations like if there are no such path, then we just return -1. So we want to check what's the case when there's no path. It's when our price destination. So if price DST, which is the final destination that we want to go, is still float infinity, then we know it hasn't even reached there within the k-stops within this for loop. Then it's either it hasn't reached there within this for loop within k-stops, or it means just there's no path there. Then we just return -1. And then otherwise, we just return price DST, which is updated, which should be updated if there's a path. Yeah, so this is how we would solve this using Bellman Ford. It's a much simplistic solution compared to the Dijkstra's algorithm, although it might be a little bit confusing because this is not the usual BFS way to do it. The time complexity of this would just be big O of edges times how many k steps are limiting us. And the space would be how many vertices there are, so how many places there are for, and it's occupied by our price list. Yeah, so thank you so much for watching, and let me know if you have any questions.